Okay, so I've made a GeoGebra applet here, a little GeoGebra program to show us what the diagonal of a cube is going to look like and finding some angles related to that. So here's a cube, and it's really neat. I can rotate it around in 3D space. And what we were looking for was the angle between a line on the face of my cube, which is right there. So a line on the face, you can see that that's right across that top there. There's my diagonal, all right? And then between this purple line here, which was just one of the edges. And we want to make this line here, this diagonal. So you can see that green line is my diagonal across the cube. The red is the line across the face, and then I've just completed the triangle with this purple line here. And if you look at it, well, first, if we look down like this, we can see it's all in one plane, cutting straight through that cube. And if I rotate it a little sideways, you can see that that definitely makes some kind of triangle. And if I look from right there, we can see what kind of triangle it is. Right there, there's the view I want. This is a right triangle. So if I put in, GeoGebra can actually measure angles, and there you go. There's that 90-degree angle in there. So we've got a right triangle. So we should be able to find this angle here pretty easily using what we know from right triangles. And I can even do some cool stuff here. I can shade it so it looks, you can really see that nice triangle we're looking for. I will go over the calculations later, but you can calculate the length of this red line, and hopefully you can see that that makes a nice 45, 45, 90 when you cut through. Here, if we look at it straight down, it'll be easier. This is a 90, 45, 45, right? Because it's a cube, this side is the same as that, so you get x root 2. So whatever side length this is, and it doesn't really matter, this is going to be s times root 2. So that's how you find that length. Now, to find this purple length is really easy. It's just that side. So once you have those two sides, you've got the two legs of your triangle, and you could find this angle by using tangent, right? You could set up tangent of this angle is this side over this side, and then you could do inverse tangent to both sides, and you get this value. And I don't know if you can see that, but 35.26 degrees is that angle. So it may look like 45, and you may want to call it 45 degrees, but since those two legs are not the same length, we don't get a 45-degree angle there.